Hello stats people, I'm just going to run through a few scatter graph tips with you all. Scatter graphs are pretty straightforward in terms of actually drawing them and plotting the points, but there can be some questions that ask you to interpret certain aspects which can be a little bit overwhelming if we don't have some sentence stems to use and to fall back on. So I'm just going to give you a few bits of advice that will help you answer quite a lot of questions that can be asked regarding scatter graphs. So let's get straight to it. Why and when do we draw scatter graphs? When do we use scatter graphs? Well, we use scatter graphs when we have bivariate data. All right, so that's very, very important. We can use scatter graphs to evaluate bivariate data. And bivariate just means two sets of data. So the reason why we'd use a scatter graph is because that bivariate data might be associated. And that's the whole purpose of why we use scatter graphs, is to determine whether or not these two sets of data could be associated, whether there is correlation or not between the two sets of data. So bivariate data is very important. We can use scatter graphs to evaluate bivariate data because this is two sets of data which might be associated. That's the first little tip. In case any question asks you why you would use a scatter graph, the answer is normally because we have bivariate data which might be associated. Next, we're going to talk about the two types of variables you can have, the two sets of bivariate data that go into your scatter graph. Firstly, you'd have your explanatory variable, which is always on the x-axis, explanatory variable. And on the y-axis, you have your response variable. Now, sometimes it asks you, how do you know which one's the explanatory and which one's the response variable? And you would just say explanatory is on the x-axis and response is on the y. However, sometimes it asks you to define exactly what explanatory variable is. So if it does ask you to do that, explanatory variables are the variables that we are changing. So we're changing the explanatory variable to see what effect it has on the response variable. So if it asks you to define an explanatory variable, we're saying it's the variable that we are changing. Now the response variable, on the other hand, if you need a definition for the response variable, the response variable is the variable that responds to or depends on the explanatory variable. So if you had, for example, let's say, let's come up with another example. We had temperature and sales of clothes. It says, how do you know which one's the explanatory and which one's the response? Well, we'd say explanatory is the temperature. The variable we are changing. And the response is the sale of clothes. It depends on the temperature. All right, so that explains for you what the explanatory and response means. Explanatory is the variable that we change, and the response responds to or depends on. Depends on is probably better than responds to. Depends on the explanatory variable. The next bit we're going to talk about is describing and interpreting correlation. So let's just do a fake example of a scatter graph. So let's say, let's have this like that. If I'm going to draw my line of best fit, there'll be a line of best fit would roughly look something like this. So we would say this is negative correlation. Because as variable x is increasing, variable y is decreasing. Now, when it asks you to describe the correlation, giving a definition like negative or weak, strong, for example, is describing it. It might also ask you to interpret it. So what it means by saying interpret, it means explain what negative correlation is. So if I'm going to interpret this correlation, I say, as the x variable increases, the y variable decreases. So the type of question you get is describe and interpret. When it says describe, it means is it positive or a negative correlation or no correlation? And interpret means describe the definition of positive correlation or negative correlation with respect to the variables. So, for example, let's go back to this example, the sale of clothes and the temperature. So we're going to say as the temperature increases, the sale of clothes decreases. We're going to say there's negative correlation there. So we're going to say describe and interpret, there's negative correlation, and then we say as the temperature increases, the sale of clothes decreases. That is a perfect example of describing and interpreting the correlation. The next kind of describing and interpreting would be the gradient and intercept. We've covered this before, but I want to go over this again. So your sentence stem for interpreting gradient would be as the x variable increases by 1 unit, the y variable increases by the gradient. So if it ever asks you to interpret a gradient question, you have to use this sentence stem. As the x variable, whatever it is in the question, you put it in there. As the x variable increases by 1, whatever the unit is, the y variable will increase by the gradient. That's how you interpret a gradient. And lastly, interpreting an intercept. So for interpreting an intercept, we would say when the x variable is 0, the y variable is the intercept.